Hello, we are in chapter 11 of the text talking about producing products and more specifically tool and equipment operation. So we're going to begin. I'm going to mention that the most important tools that we as humans have, of course, number one is our brain, number two is our hand. But when we talk about tools in general, that refers to different types of hand and power tools or any device that's kind of used by a person to perform tasks and to do work that's one operation at a time. We do classify into three different types of tools. I'm going to break these down into hand tools, power tools, and equipment. We're going to talk about the differences between the three and what advantages and disadvantages of each are. And then we're going to basically kind of refer to the different sub industries. So as you start your career and begin to work in manufacturing or in any other industry, all sub industries basically have different types of tools that you are going to need to be aware of, know how to use, know how to maintain, know how to set up, know how to diagnose. Whatever the tool is, you're going to need to become confident and competent in being able to use that for your tasks on the job. So, what exactly is that tool? Well, again, we could talk about hand tools just basically being an extension of the human hand. Of course, we provide the power for that. We will get into different power sources for tools. So, um, and you need to consider how to hold that hand tool and what the best case to use it is. When we get into power tools, there are versions of power tools that basically are the same thing as our hand tools, except now we have a different types of power source. And generally, those power tools make it easier for us to actually do the work and kind of save us some different types of tension or stress in our hands or muscles, or make it easier for us to do that work. So if you consider, screwing a screw into a outlet, obviously there's going to be a difference between using a handheld screwdriver versus using a bit that's on a hand drill attachment. And you've all probably experienced that type of work before, where you use both a hand driven screw driver versus bit on a power tool. When we talk about equipment, we're getting more and more complex. So usually your equipment is stationary, so it's not easily moved. Hand tools and power tools, of course, are movable. They can go back and forth from job site to job site, depending on where the work is. Generally, the equipment is much, much more stationary and designed to stay in place. It can still be operated by a human by use of some type of foot pedal or lever or crank, but most of the time it's going to have a power source and a lot of times it's going to be able to prepare more or do more than one operation at a time. So if you think about a progressive die or some type of a punch press and stamping presses, lots of times they can do more than one task all at one time. So let's quickly talk about some of the different power sources. Basically, we have electricity, battery power, hydraulics, pneumatics, liquid fuel, and yes, we still use human or animal to power our tools depending on what area of the country or world that you're in. Animals power and human power is still pretty much mainstay there. So electricity comes from outlets. Batteries, of course, are portable, so and they're stored energy in that battery. Both of those get their power source from the same area. I mean, we have to recharge a battery basically plugging it into an outlet. Now, some of the differences, of course, with electric drills, let's just kind of talk about, and I'll use the case of a drill again. An electric drill, I'm going to be kind of tethered to a close proximity of wherever that outlet is. Whereas a battery powered drill allows me to kind of move about more freely and take it with me. Now, the advantage to the electric drill is, of course, a more steady, consistent power. So on the battery power pack, that battery's going to wear out, and I'm going to lose power at some point while I'm going in and having to recharge it. So there are advantages to both. You can think of some different types of hydraulic or pneumatic tools as well. If you think about scissor lifts or lifts for your automobiles. Those are typically hydraulics. We have all sorts of pneumatic type of um, tools that are, say, maybe rotary tools might use air pressure to kind of turn the actual cutting tool. So we also have pneumatic air guns as well. So our pneumatic nail guns and so forth as well. So those are some examples. And of course, if we're talking about liquid fuel, a lot of times, lawn mowers or leaf blowers, some of the different types of tools that you're using outside to do work are kind of powered by your liquid fluids. So I do want to mention, going back to hydraulics here for just a minute. We typically talk about this being a fluid. It is generally hydraulic oil. There are dangers to using hydraulic oils. So we could also be using water, although oftentimes there's rust issues. So generally it is an oil. But I do want to kind of make this remark, even though we call hydraulics as a separate power source from pneumatics, they are both fluids. Air pressure, air is a fluid just as well as water and oil. So, of course, there are different viscosity ratings and so forth there. But we do, both of these, hydraulics and pneumatics, are working under high pressure to achieve that transfer of power. On a side note, not used too often anymore, although it's kind of coming back into vogue a little bit. So we have a resurgence a little bit in terms of using wind power in as far as windmills to generate electricity. So we're not really putting these on any of our hand tools or power tools yet, or even our equipment. But of course, we are using wind energy. We can and still can use steam engines to power and make electricity there as well. And of course, if you talk, a lot of our hydroelectric power is still kind of being used by dams across the nation. If you think about like the big Hoover Dam, or even going across over in Indianapolis, there's a big dam. Clinton, there's a dam there in Clinton that oftentimes can be used to generate and um, turn a turbine and help generate power there as well. So now that we've gone through some of that, we will talk about the 6 processes that you use tools, that we can kind of break tools into. So measuring, of course, is very, very important type of process that we use. Separating is anything that we're going to be using to remove part of the material to bring it into the size and shape that we need it. We can talk about forming material here as well, which is going to shape that material. So we talk about combining, where we're putting pieces together using different types of subassemblies or finished products. We're going to mention and talk about conditioning, how we can change the structure of materials or parts of product using different types of conditioning processes. And then, of course, we'll also talk about coating and finishing processes that allow us to cover one material with another for different applications and for different reasons. So let's start out with measuring, marking, and layout tools. So pretty much everything in industry, you do have to be able to measure and whatever it is that you're working on. So now we can kind of talk about linear measurement, or we can talk about volume. So there's several different types of measurement that we will need to be aware of depending on what it is that we're doing and where we're working. But all of these measurements are accurate and vital for us to maintain and produce the products that we need and meet quality demands that we're looking for. All of our tools that are involved in measuring also will have some type of calibration system or some way to make sure that it is accurate and referenced off of a known standard so that we can comply with different regulations or different standards that we need to make sure that our products are made to. So the different types of measurements are laid out here. So I mentioned about linear measurement, angle and level management or measurement is also there. So in both of these, when we're talking, your standard tape measures, rulers, and calipers and micrometers are all types of tools that would be used for linear measurement. If we talk about angle or level measurement, we're talking here now about the um, polar coordinates and a way to kind of measure degree as well. We get into electrical measurement where we're looking at different qualities like voltage or current, resistant, using instruments like multimeters and other types of digital tools. Volume measurement is important as well. So we can kind of calculate three-dimensional space or maybe the amount of movement or constriction in hydraulic or pneumatic fluids. So, and then of course we also have temperature measurements as well, especially in those are especially useful in chemical or plastics and food and beverage sub-industries, where getting a product to a certain temperature is vitally important, whether that temperature needs to be higher to kill off bacteria or high enough to kind of create the mixture to or make sure that some type of catalyst reacts. Those are important things to happen as well. So if we talk about some tools, I've already mentioned in terms of linear measurement, from a precision manufacturing standpoint, we'd be talking about calipers and micrometers. Of course, we all, pretty much everybody should know how to read rulers and tape measures down to a 16th of an inch, if not a 32nd or 64th. Calipers and micrometers are going to give us even tighter tolerances where we can measure down to the thousandths of an inch. That's 3 decimal places. Or in case of the metric system, we would need to be able to measure into microns as well. So we would have to learn how to use those measuring tools correctly and how to read those measuring tools as well. So we get into angle and level measurement. Now we're talking about protractors, compasses, squares, and levels that can all be used to measure that. Electrical measurement tools or gauges, multimeters, oscilloscopes, voltmeters, ammeters, all sorts of other types of sensors there as well to kind of give us a read in terms of electrical measurement. We're looking at volume measurement, beakers, flasks, they're going to be marked. Think about your graduated cylinders where you have some type, whether it's milliliters or liters or gallons, pints, whatever, ounces, whatever that unit is, they're going to be measured in that. And of course, we can also use the displacement method using different calculations to determine volume of substances or items there as well. We get into temperature measurements. Of course, you're all familiar with thermometers. We can also use thermistors, thermocouplers, RTDs, and other sensors there as well that would help us in that regard too. Next category here is separating tools. There are two ways to separate material. So, and that is a mechanical means. So, in the sim lab, we're going to basically be using metal shears. So, to separate, we might use the lathe or the mill to more or less cut and remove material that way, or other methods is chemical means. So where we're basically using chemicals to break down, have a chemical reaction to break component parts into the different types of substances that are needed there as well. Given some ideas here, some of the tools, again, mechanical means. So we talk about cutting or machining. That's what we refer to as a subtractive process where we're removing material, usually in the form of a chip. So those methods include sawing, so we can drill, mill, laser cutting, and water jetting are all ways to kind of separate there. We have the process called sieving. So where if you think about like the old prospectors where they had like a wire mesh and they would basically be putting dirt and gravel in there and shaking it. That's sieving. Filtration. So lots of times in different environments where you've got some types of a coolant or maybe grinding grit or grinding dust, you want to pull that grinding grit out of there. So the only way you're going to do that is to filter it and kind of run everything through a filter so that the coolant passes through, but the particulate matter is left on the filter, so that's called filtration. Sedimentation would be where we're allowing those particles to settle down at the bottom of the liquid. Going back to that same grinding dust analogy, oftentimes when you're filtering things through, that sedimentation of that grinding grit can oftentimes kind of also fall to the bottom, and then it might be a method where you at some point are going to need